Good morning, good afternoon, and good evening, depending on where you are. Welcome to Microsoft Build 2020. Welcome to today's session using Azure Spatial Anchors to build mixed reality applications at world scale. My name is Matt Fleckenstein. I'll be your moderator and your co-host today. I run marketing for mixed reality here at Microsoft. My colleague Nina is going to be joining us. Nina, you want to say hi and introduce yourself?
Hey Matt, hey everyone, thanks for watching. My name is Nina Cometh, and I run our Azure Mixed Reality Services product at Microsoft.
Awesome. So Nina's going to come back on in a little while and tell you a little bit more about Azure Spatial Anchors. But before we go there, I'm going to kick things off and just talk a little bit about what mixed reality is and kind of how we got here. I think we can all agree that cloud computing is arguably the biggest secular trend in computing in the last decade. It's really fundamentally changed the way that we build, manage, and deploy our applications. But perhaps more importantly than that, it's fundamentally enabled every company to become a technology company. And while the cloud has actually offered us great things and gotten us most of the way there, it simply can't overcome the laws of physics, things such as the speed of light. As more and more people and devices get connected at the edge, there's a need for ultra low latency computing that really can imbue the power of AI and mixed reality to enable these next generation experiences. So today, we're at a point in time when we're entering what we call the fourth wave of computing, where ubiquitous computing at the edge that really enables you to blend the digital and the physical worlds into these seamless experiences. And I think you'll see that from some of what Nina's going to show today. But if we take a step back in the early, in the 1970s, we really kind of started to realize the power of computing for individual workers through terminals and mainframes, where individuals were literally tethered to their desks. In the 1990s, it came the era of personal computing, where we actually, for the first time, started to have computers as we got laptops that we could take with us on the go. But it really wasn't until the 2000s, when smartphones became ubiquitous, that we really had a computer in our pocket that we could take anywhere with us. And we started to realize the potential of things like contextual awareness and our location in space. Never has that been more true, though, than with mixed reality, where when blending the physical and the digital worlds, we've got these incredible opportunities to create these experiences that we've never seen before that fundamentally transform the way we work, the way we study, and the way we play. But these opportunities, while great, are not without their challenges. My good friend Mo Ben Zachariah, who's the chief technical officer at a company called Spatial, one of our mixed reality portfolio companies, just says it the way it is. Connecting the digital with the physical worlds is, quite frankly, full of challenges. And nobody knows that better than us here at Microsoft. But to talk not just about these challenges and maybe share some of the things that we're doing to overcome these challenges, I wanted to have Nina come and talk with you all and share some of the experiences that she's learned about leveraging Azure Spatial Anchors and creating these immersive 3D mixed reality experiences really at world scale. So with that, I'd like to invite Nina to come back in and share a little bit about her perspective.
Thank you, Matt. Hi again, everyone. And I'm Nina, and I lead our Azure Mixed Reality Services area at Microsoft. Now, as Matt just said, there are still many challenges in building mixed reality applications. And a few years ago, we realized that in addition to providing the power of the compute at the edge with HoloLens, there were also opportunities to really help developers complete their customer scenarios via some services. So we have two services here. Last month, we were really excited to announce the public preview availability of Azure Remote Rendering. And this week at Build, we're really excited to announce general availability of Azure Spatial Anchors. So let me first talk just a bit about Azure Remote Rendering. Many of our customers in mixed reality have these really complex 3D models that they're looking to visualize. So say, for example, in architecture, there's an architectural model, or in manufacturing, there might be a car engine design that you want to review. And technical artists, designers, engineers have spent weeks perfecting these models, designing them, working on them. And when they bring them into mixed reality, they want to see these in full fidelity with high polygon count. What Azure Remote Rendering does is render all of the high compute in the cloud and stream down just the frames so your application user sees all of the detail that they want to see. It's pretty cool. We hope you check it out. Now, today, I want to spend most of the time talking about Azure Spatial Anchors, which is what we're going to deep dive into. So let's get started, Matt.
All right, sounds great.
So, one of the fundamental challenges in mixed reality is how to keep your digital content locked to the same physical world location over the course of time. This is called persistence. And another one of the fundamental challenges is how to then share that digital content in that exact physical world location with the others around you. This is called sharing. Now, persistence and sharing are pretty basic, normal concepts in life that we just take for granted. Say I was working on a jigsaw puzzle over there on my coffee table. When I come back the next day, I would expect it to be in pretty much the same state, or else I'd wonder who helped me out and completed my puzzle for me or moved it, right? And that's persistence. Now, say that my husband walked in the room and I wanted help with that jigsaw puzzle. Well, he would immediately see it. We would work together. That would just be there. It'd be natural. And that's sharing. And these concepts that are simple in real life, in our real world, are actually a little bit complex in the digital world. So Azure Spatial Anchors exist to help developers with exactly these concepts in the digital world, sharing and persistence.
I think that's great, Nina. I actually need some of that persistence. I think for the jigsaw puzzles I've been doing with my girls, every time I turn around, they seem to mess them up and they don't really persist. So I'm
Lose a few
definitely into what you're
pieces?
saying. Exactly.
Absolutely. Now, jigsaw puzzles and mixed reality at our coffee table in our living room is pretty interesting, but it gets a lot more interesting at world scale. So, we really had the opportunity at Microsoft a couple years ago for the Azure Spatial Anchors team to partner with our Minecraft team to really bring a world scale mixed reality experience. The Minecraft team was looking to bring the digital world of Minecraft into our real worlds all around us, all around the globe. And we call this project Minecraft Earth. Working on Minecraft Earth, we've learned a lot about what it takes to create a world scale mixed reality experience. Now, before I get into those lessons, I thought I'd kind of take us back in time. A couple years ago, when we started this project, we sort of had an idea of what we wanted, but we were creating some early prototypes to really see what it felt like, what was the magic. And in one of these prototypes, I was playing with one of my coworkers, Jesse. We were play testing one of these games. And Jesse had his phone in his left hand and was shooting arrows at a skeleton, trying to beat the adventure. And with his right hand, he was saying, "Over there, Nina, over there." And he was pointing to me where he wanted me to help out with additional skeletons that were coming our way. And he had sort of completely forgotten that, he's looking through a phone and pointing into the real world. He had become completely immersed in this digital world simply by the screen of the phone that's in his pocket. And we knew that we had succeeded because we sort of found this magical moment. And we knew there was something here that we wanted to bring to all of the players. Now, what did we learn through all of this, through these last couple of years of building this experience? Well, let's go back to the basics a little bit. An anchor in Azure Spatial Anchors is a precise point of interest in 3D space that can be shared across users, devices, and time. This means that an anchor is really fundamental to kind of blending between your digital and real worlds, as it is that entry and exit point between these worlds. So creating and finding these anchors has to feel natural and intuitive for your application users. And let's learn a little bit more about that and how we do that. Now, Azure Spatial Anchors is built such that every user who finds an anchor is contributing data for that anchor. That data from different devices, different perspective, different periods of time from all different application users makes the Azure Spatial Anchor data and algorithm improve over time. It understands the space better, and the quality of the algorithm, quality of the experience gets better the more that it is used. So creating that first anchor is really just like laying down the first brick of the foundation of a new house. There's a lot more to come. There's a lot more rooms to design, but the first anchor does determine that starting location and what's to come afterwards.
That's awesome. That sounds like a great little tip, right? And kind of something to keep in mind. Curious, what other types of things you guys have learned as you've actually built out these Minecraft Earth experiences.
Yeah, so let's start about really on the creating anchor side, and we'll get to the finding anchors. One of the first things we found as we were building the experiences, there are different personas in every application. And in a game, you might have an explorer or a collector persona. This is someone who loves going out into the world and collecting all the items for the first time, conquering certain areas of the world for the first time. They get a lot of joy into it. And in addition, this provides value for the other players down the road. Now, this isn't just about gaming. If you think about a retail application, say a shopping mall or a store, you likely have a curator or moderator of the store who's going to go and set up a shopping experience for everyone else to come. This happens in the real world too, right? When you go into your favorite store and you see those beautiful racks tempting you with exactly what you were looking for, somebody put a lot of thought into setting that up. Similarly, you might be, looking at a tour in a museum, and that had an immense amount of curation to make sure that all the art and the talent really shines. So it's a really unique opportunity to make sure you cater to these application users, the explorers, collectors, moderators, so they can set up the space in just the way that they want to for the next users to come. Now, one of the things you want to do when you're setting up an Azure Spatial Anchor for the algorithm is to encourage rotation and translation with the phone. It's not very exciting. I mean, I don't think I've told any application user about rotation and translation and had them really grok that. So, a more fun way to do it is really to think about encouraging curiosity and interest by lighting up feature points. Feature points are available on most AR platforms, or by thinking through mini puzzles and projects that really encourage movement. We had a ton of fun prototyping a number of these, and let's watch a few of these, Matt.
Sure thing. So Nina, it was great watching those videos, but I just want to make sure I'm following along. Basically, if I go back to what you said in terms of laying that first brick, encouraging kind of this movement, right, and people to kind of move around. So that's actually helping to create a better experience. Am I following that right?
Exactly. Encouraging this movement is creating more data for the anchor when we first start out, and thus is creating a better experience for later players that come along.
Awesome.
And as you might have felt, Matt, when we watched those videos, didn't feel like we were doing something onerous, right? Just felt like we were playing a game.
I like that flying thing for sure.
um, so another note, now this isn't about Minecraft Earth, but it's something I thought was really cool in another application I've seen. There's an application called WorldBrush on iOS that actually uses phone motion as a core input tool to the experience. So your phone itself can become the paintbrush you use to paint into the world. So that's a very cool idea. And we love seeing what the world sort of comes up with in designing these sorts of mixed reality experiences. And then lastly, landmarks. Landmarks are your friend and they're the algorithm's friend. Landmarks are really visually interesting, unique points for the Azure Spatial Anchors algorithm. Our computer vision loves that stuff. But at the same time, landmarks can really light up your application user's experience by being able to, you know, pull up something historically interesting or a fact that somebody wouldn't know by showing that right around the landmark.
Awesome. So that's a lot of great stuff about creating anchors. What about actually, finding anchors?
Yeah, so finding anchors. Now, we just talked about the first player. What about every other player that comes afterwards? That's what you're wondering about. So, with finding anchors, you can leverage a lot of the same tips that we just gave in terms of designing your application. But in addition to that, let's talk about maps. We're all familiar with maps. We probably all used at least one maps application today, but there's a few additional tricks that can really help. The first is mini thumbnails on maps. You can enhance map views by adding mini thumbnails and images that you capture during the creation time of the anchor. And like I show in this left-hand side image here, if you've been to the Microsoft Commons before, and that's a frequent spot for me, uh, as soon as I get there, and even with this tiny little image there, I know exactly where the application is sort of naturally telling me to look. And we found a lot of users naturally cue in to these kinds of small images. The other is to use a satellite view. We did early testing, and we found that many more of even our own employees and colleagues that I work with were able to more easily find the anchor via using a satellite view than a traffic view. Because your brain sort of naturally gets cued into, hey, maybe I should be like on this side of the grass or over there by the trees. And lastly, using application sign in and load in time can really help make this feel fast and seamless for your players. A lot of times you can just turn on the phone camera and begin finding the anchors such that by the time your application loads, the user already feels like, oh my gosh, the phone already knows exactly where I am in the world. And that has made it feel very smooth. Now, thank you for listening. And if you don't take away anything but three things from our brief chat today, I hope it's these three. First is that this concept of persistence and sharing, which is really natural for our real world, takes a bit of effort in mixed reality, but is fundamental to blending the real world with the digital world. Second is that Azure Spatial Anchors enables this persistence and sharing for your mixed reality experience, whether it's room scale or whether it's world scale. And lastly, we would love to help you and we'd love to learn with you. We hope you check out Azure Spatial Anchors today. It's available in general availability. And please reach out to chat to us. We'd love to hear from you.
Awesome. Thanks, Nina. Hey, I've got a bunch of questions rolling in. Clearly, some good interest. Maybe one that I'll kind of start with. I've got a question here just around the notion of persistence. You talked about it in your jigsaw puzzle example, right? The question is basically how long do anchors persist for, and who has access to them?
It's a great question. So with Azure Spatial Anchors, anchors persist for as long as a developer wants you to. By default, they persist forever. Now, in certain cases, we've heard our developer customers say that, I actually don't need this to persist. I've done my puzzle and I'm cleaning it up and I'm done with it. In which case, you can set an expiration date yourself on the anchor if you decide. Now, Matt, could you remind me of part two of the question?
Yeah, it was just around kind of persistence and how long they last for, and then also if you could just talk a little bit about the sharing side of it, right? You talked about sharing these experiences with other people. What types of devices can you share on? Those types of things.
Absolutely. So with sharing, in Azure Spatial Anchors, you can share across HoloLens 1, HoloLens 2 devices, and iOS and Android devices that support ARCore and ARKit today, which is a long list of devices. And we're super sort of excited to provide this platform in whatever language you choose to code in. Might be Objective-C, might be in Java, might be in C++, and we're excited to see your applications across all of those.
Awesome, thanks. Hey, I have a good question here. How do you ensure privacy when you're scanning the world, right? Are there image textures or just a set of abstract feature points, right? Those types of things. So I know this is certainly something that we kind of dealt with when we were kind of, going after the Minecraft Earth opportunity. You want to talk a little bit about that?
Absolutely. Privacy is really important to us, and Azure Spatial Anchors does not take your images to the cloud. What we do actually is use abstract points called feature descriptors that the backend computer vision algorithms understand. And we actually have an entire blog post on privacy in Azure Spatial Anchors. We encourage you to go check it out and learn more with us.
Awesome. So, hey, Nina, I have a question. One of them was there was a question around what are some of the other applications where you're seeing people use spatial anchors beyond just the types of gaming experiences that you showcase with Minecraft Earth?
Yeah, absolutely. So, we're seeing applications across retail, manufacturing, healthcare, a number of different verticals. I'll go into one of those. I'll go into manufacturing, which is something I'm pretty excited about as well. We've had some customers who are working with manufacturing such that you can connect a lot of your backend data, say data about when was some equipment last maintained, what is the status of the equipment, data about your IoT sensors that are connected, and visualize all of that data in situation as you walk around your factory. Being able to walk around and really just say, all right, I'm looking down this set of workstations. Oh, I see that one of these is actually running much slower than the others. Maybe I should go check it out. And this is all available to you, heads up, hands free, in mixed reality in your real world, rather than having to walk around and stare at a tablet or go back to your PC and reason about your 3D space at a PC.
Yeah, you know, that notion, you talked about kind of an example in manufacturing, right? It was kind of blending IoT and mixed reality worlds together, where you have contextual data that you're overlaying on top of the real world in a work setting. For those of you who have seen, kind of some of the keynotes at Build, you've gotten a chance to see the role that mixed reality has been playing in helping, with some of the pandemic, overcome some of the pandemic issues. Whether that's actually frontline or first line patient care, or actually helping companies to train folks to produce ventilators or PPE to keep up with demand. I think one of the things that's interesting and one of the pieces of feedback we've heard is, people love the ability to kind of anchor and share certain data about a patient, because by wearing a device or using a mobile device, by wearing a HoloLens or using a mobile device, they can all see the same patient data without having to kind of crowd around an actual physical screen together. And so in this time period, where, when they're practicing social distancing, we've seen a lot of uptake and excitement just around that very basic capability of doing those types of things.
That is a great point. It's been super interesting to see the acceleration we've had due to all the changes in how life is running these days.
Yeah, there's no doubt, right? It's more and more kind of push toward kind of working remotely and finding new ways to kind of collaborate. So for sure. Hey, one question I have here is, someone was asking about, in terms of when you place these anchors, asking about accuracy, and accuracy, particular in comparison to maybe, some other technologies that are out there. Think about kind of Wi-Fi and kind of triangulation, kind of those types of things. How would you kind of describe the accuracy of dropping anchors and restoring anchors?
Absolutely. You know, some sort of think about this Azure Spatial Anchors technology as a much more sort of accurate, more precise GPS-like technology, because you find out where you are just in the order of centimeters rather than multiple meters or tens of meters. And the way I would really think about accuracy on Azure Spatial Anchors is that it is different device to device. HoloLens, between HoloLenses, we tend to have centimeter level accuracy, and between mobile devices, which have a little bit more limitations where when it comes to mobile device tracking, we tend to have tens of centimeters of accuracy. But these are scenarios where exactly you are. Are you right in front of the table? Are you right under the tree? These kinds of things really matter, and this is what we're looking to support.
Awesome. Hey, one more question here that kind of it kind of starts to bridge a little bit back into kind of the privacy thing, but it's a
Mhm.
little bit more broad than that, which is, do you have as you kind of set anchors and place content against anchors, do you have the ability to control who sees kind of that content?
Absolutely. Um, I'll talk about kind of two levels of control I think will be interesting for folks. One is the anchors themselves, and the other one is the content. Azure Spatial Anchors deals entirely with the anchor data. And our service is set up such that a developer can decide the tenants or multiple tenants that they want to support. So we don't take this data and publish it for the rest of the world. Um, this is really available, say that work at Starbucks or you work at T-Mobile. Those become your anchors as a developer and the owner of that. Now, on the content side, Azure Spatial Anchors does not address content at all. This is all up to you. Wherever you store your content, your databases bring them with you. and kind of run them however you choose. And so that is so sort of the two layers of data ownership there.
Got it. That's great. Hey, here's a question about spatial anchors, right? And basically, can you talk about the differences of spatial anchors for AR Core and AR Kit, and how it's different than spatial anchors for HoloLens?
Sure. Matt, I missed the first part of the question hearing you. Do you mind repeating it?
Yeah, no, not a problem. Can you talk about how spatial anchors for AR Core and AR Kit is different than spatial anchors for HoloLens?
Absolutely. So we have worked hard to make spatial anchors first class citizen across all of the different platforms we support, AR Core, AR Kit, and HoloLens. Now, as I was mentioning earlier, some of the quality and performance of spatial anchors are limited by the native tracking system. With AR Core and AR Kit, when you're on a phone, it's in your hand, it's a smaller field of view. The tracking quality of the base native platform tends to be a bit more limited. And so we achieve a bit less accuracy on mobile devices, but we're aiming to, again, be as equal as we can across all of them and have them all be an amazing experience.
Awesome. Here's one about spatial anchors. Do spatial anchors work inside without GPS location data?
Yes, they do. So when you use Azure Spatial Anchors, you may optionally choose to also include GPS data, Wi-Fi data, Bluetooth beacon data, but you don't have to, and it does function without that.
And what are the advantages of including those other things?
Now, when you include course relocalization signals, this is what we call them, it can help you additionally with it can help the algorithm with separating things like two rooms that look the exact same but might be on different floors or in different buildings. It can help us optimize on the back end for a better experience. Now we run a lot of the same optimizations with or without those signals, but additional data, always a good thing.
Yeah, for sure. Those algorithms love their data, don't they?
Yes, they do.
Awesome. Hey, I think maybe we have time for kind of one more kind of theme here that I'll hit on. There's a couple of questions about just kind of spatial services in general, right? And so you talked about specifically, applications of spatial anchors, relative to kind of gaming and finding very point things. What are some of the other things that we're seeing at Microsoft where, kind of spatial awareness and context, could really be helpful in terms of creating these kind of immersive experiences?
Absolutely.
Maybe
Well,
maybe said another way, like where is this all going, right? What else is kind of coming down the pipe?
yeah, that makes sense. Um, I think there's a lot of things coming, but maybe I'll speak via example about something I'm really passionate about and I've seen a lot of customers also passionate about. Spatial anchors, as I mentioned, are really precise points in 3D space. This is the beginning of understanding our space in 3D and really eventually generating our digital twins in 3D. We've had some interesting content on digital twins here at Build as well, which I encourage folks to check out. But a lot of the way we think about, the world at mass thinks about digital twins today, it's still kind of limited to 2D. We've had so many customers tell us, hey, I'd like to be able to walk into a building, scan it, and get a 3D model of it. I want to be able to then sit at my office and be able to monitor each of the different sensors, know exactly where they are. I want to be able to have someone who works in maintenance, then be able to go into a building they're completely unfamiliar with and get immediate directions to the sensor that they want to take a look at. And when they get there, I want them to be able to see that IoT data visualized right in front of them so that they can know exactly what to fix. And this kind of end to end seamless experience that blends IoT, digital twin, mixed reality, sort of 3D all together. We're really looking forward to that, and we think that's going to unlock a whole new world of possibilities.
Awesome. Look, as someone who is eternally getting lost, I crave the day when I can kind of get a map that'll literally guide me from point A to point B and really put me into an experience that feels just like the one I'm actually seeing with my eyes. So can't wait to see where this goes. We're about out of time. I know there's a bunch of questions we didn't get answered. Encourage you to go check out, Azure Spatial Anchors. As we talked about, it's generally available, so go take it for a spin. And want to thank Nina very much for coming and talking to us, and want to thank all of you. for participating in this session. So thank you very much. We greatly appreciate it, and I hope you enjoy the rest of your build.